Okay, so the second presenter of this session is from Japan side. So he is a Dr. Hiroshi Yokota. So he is a Professor Emeritus of Hokkaido University and now works for Coastal Development Institute of Technology, Japan. So he has been appointed as a committee manager of ISO TC71 and a convener of ISO TC71 Working Group 1. So his major interest includes the life cycle management of civil infrastructure, including durability design, performance evaluation, prediction, and interventions. So he is currently trying to incorporate the sustainability indicators in the life cycle management system for decision making, in which sustainability would be objectively evaluated at the design and use stages. It's a long introduction. So he wrote. Okay, so please welcome Professor Yokota.
Good morning, participants. Thank you very much for your kind introduction, Mr. Chairman. I'm Hiroshi Yokota from Japan. So today I'd like to present my idea about how we specify sustainability in code for concrete structures. It is my great pleasure and honor to be invited in this session. And sustainability, as Andy presented just now, is not the very stiff definition so far. So we are going to make some provisions and statements in the design codes. So I'd like to show some examples and how we are going to make some specifications in the design code. So today I have ideas about sustainability to be covered by structure design code and standards. So how we are going, we or I am going to include sustainability related specifications in the design codes and standards. And I'd like to show the 3 examples of design codes that already exist: ISO 22040, published in 2021, relating to life cycle management of concrete structures. And the second one is ISO 19338, published in 2014, and now under the revision stages, because the ISO document should have the internal evaluation. It's every 5 years. Now this ISO document is in these stages. So we are revising this document to be ISO working draft 19338 that I'd like to show the current situation of this division. And the third one is the Japanese domestic design standard of the JSC, Japan Society of Civil Engineers Common Code for Structural Design. This is in the middle stage of the development. I'd like to show you the idea of this document. So first one, I'd like to about the definition of sustainability. The definition of sustainability is relating to this document, that the ability of structural element to contribute positively to the fulfillment of the present needs of humankind with respect to nature, society, economy, and well-being, without compromising the ability of future generations to meet their needs in a similar manner. So this definition was already mentioned in the ISO document and FYB model code. So you can understand that sustainability is a very important idea, how the structures, not only for concrete structures, but also any kind of structure should seek the possibility of in the future trends. And sustainability can be considered as the 3 pillars in this slide: the social, environmental, and economical aspect. So the social aspect is one of the very important sustainability aspects, because it covers the effect of structures on the society and some economic and social activities of humankind but through the structure or by the structures. So this is very important. And quality of infrastructure, safety and security, accessibility, user satisfaction level, cultural preservation, and so on are one of the examples of the indicators of how we evaluate the social sustainability. Resilience or robustness of the structure is one of these social sustainability evaluation indicators, I think. And the second one is the environmental. So environmental, everybody knows the importance of this document and all the presentation of environmental issues. But sustainability is not only for the environment, but also some social, economic. It should be not forget about that. So environmental sustainability covers the climate change, resources, pollution, biodiversity, ecological systems, and so on. It's how the structure or structural system affect on the environmental burdens or environmental preservations near the structure or more widely over all our globe. And economical sustainability is very common because every designer, every engineer can count the cost for the construction structure and maintenance structures. But the economic sustainability is not only the cost, but also we should consider the benefit derived from the structure or efficiency or even the value of the structure can be the indicators for evaluation of economic aspect. So the sustainability of these three pillars, how we are going to include in the design codes. So this is our most concerns of the sustainability. Another issue is about the life cycle management. So the structure is divided into three stages in terms of life cycle considerations. One is the procurement stages, the next is the use stage, and eventually life end stages they have. So procurement stages including the vision, plan, surveying, design, and execution, how to construct, how to design, or how to provide the structure with the people. So this is just before the starting the use stages. This is the procurement stage. And use stages probably is the longest period of the life of the structure, including the operation, conservation, upgrades, and so on. So through the maintenance work, we should consider the use stage, how we keep the structural performance of structural functions to be satisfied in the design and constructions. And eventually it comes to the life end stages. So probably disposal or replacement by the new structure and so on. So at the life end stages, we should consider how to dispose the structure, or how to recycle, reuse, or how to replace the new structures. So this is very important, but actually at the design stages, we are not easy to consider how we stop using the structures, but we should do it from the sustainability point of view. So you can understand that the sustainability considerations is a very close relation to how we manage the total life cycle of the structures. So from our experience, design engineers can only consider the design, and the construction engineers mainly consider about the construction. And the maintenance, inspection engineers always use how to maintain the structures. But they are not done independently. They are close relation to each other, and the coordination of the work are very important to realize the sustainability of the structures. So the coordination of all stages, all overall management concepts are very important. And through the life cycle management, we should respond to the expectations of the people and society throughout the life cycle of structures. Of course, we should ensure the performance requirement of the structures. Okay, this is a very important matters under the performance-based design philosophies. So the performance or function of the structure is very close related to the objective of the construction of the structure. So we never forget about the performance requirement throughout the life cycle management. So through the life cycle management, we should assure the sustainability of the structure and the people and society around the structure. So engineers should consider not only the sustainability of the structure, but also the sustainability of the people, society around the structure. So this is a very, very wide global idea how about sustainability should be incorporated in the life cycle management. So this slide is very small, so sorry, but this is the flow of life cycle management. We will make the strategies. Okay, in this slide, it is written as a scenario. So how we realize the sustainability of the structure, how we ensure the performance requirement of structure. This should be well considered very beginning of the life cycle of the structures. Okay, some people consider such strategies as the use stages, but it is very late. Okay, how to realize the structural sustainability should be considered at the very beginning of the life cycle, particularly for the initial design or basic design of the structures. Okay, and during the procurement stage, we should draw up the basic life cycle management scenarios, and this scenario is always updated to reflect to the current situation of the structures. Okay, and of course, design, execution, and maintenance work should be done with an individual scenario for each stage. So you can understand that we need some very close coordination among the structures. And for the sustainability requirements, at first we should set up the how we realize which aspect or which detailed aspect of the sustainability should be ensured during the life cycle of the structure. So we collect the basic information about the sustainability of the social, environmental, and economic aspect. And performance and sustainability requirement will be determined before starting the verification, and structural profiles, material production, and construction method and so on will be considered based on the performance and sustainability requirement. And then we set up the indicators for evaluation of sustainability throughout the life cycle of structures. Then we make the next stage of design, construction, and maintenance work. And before starting that, we should verify or evaluate our basic scenario is reasonable or not. Okay, basic strategy is okay or not. Is something wrong? Something we can find the improvement of our basic scenarios. We should modify the requirement should be changed, or some method of the design, construction, and maintenance will be improved, or also the indicators for evaluation sustainability should be reconsidered and so on. So we should some modification to be made, and to the such iteration work should be done until everything can be satisfactorily verified. So sustainability indicators in this flow can be used as a performance requirement, if possible, for structures, and for some evaluation indicators to choose the most appropriate options or solutions among the alternatives. So that there are two ways of the usage of indicators for the life cycle management. One is a performance requirement. The second one is just for indicators for the decision making. This is not explicitly defined during the life cycle of structure, but anyway, sustainability should be considered either the requirement or somehow effortive basis. So these are some parametric study, preliminary parameter studies already published in the FYB International Conference 2016 about the sensitivity of these indicators related to each other. This one was social indicators in terms of the overall safety margins relating to the resiliency or robustness of the structures. And this axis is the economic sustainability indicators in terms of construction costs. The other one is environment indicators in terms of carbon dioxide emissions. So you can find that how is the most suitable solution can be found among these parametric studies. So it can be proposed as this paper. So if you can have some interesting about that, so please refer to this document. Okay, and the first example about the sustainability design code is ISO 22040. Okay, it's published in 2021, and the table of contents in this code is given in the right-hand side, this slide. So you can see that the indicators for life cycle management, okay, this is similar to the indicators for sustainability evaluation, like social aspect, environmental aspects, and economic aspects. Is already included in this ISO document. So this document entitled Life Cycle Management Concrete Structures, and it was developed by the TC71, ISO TC71 Working Group 1, Life Cycle Management Concrete Structures, and the convener of this working group is I myself. And this project started in September 2016. We needed 5 years for the publication, and finally, the January 2021, it was published. And it covers the framework and the general principle of life cycle management. It is not specific document can be covered in this document. So that's why we are making another series of documents relating to the life cycle management. For example, part 2 is the life cycle management, particularly at the structural planning and the design stages. Now, under the development at this moment, it is now the committee draft stage. And also part 3, execution stage, also under development. This is a working draft stage at this moment. So these two parts, we can provide a much more detailed specification how we consider the sustainability in these stages of life cycle of the structures. And clause 5 of this document, so general framework of life cycle management, we gave such specification that when implementing life cycle management, appropriate scenarios shall be created as measures to ensure the performance requirements are met during the life cycle structure and the indicators are set appropriately. So we should set up the performance requirement with a particularly suitable indicator to evaluate as the life cycle of the structures. And the basic scenario shall include the fundamental strategies and how the structure will be managed in terms of the sustainability aspect. Okay, sustainability aspect including not only the environment, but also the social and the economical aspect. So these indicators should be involved in the design if possible. And appropriate indicator necessary for the assessment of life cycle management scenario shall be set for sustainability factors regarding the social, environmental, and economic aspect. Okay? So these indicators shall be calculated with respect to the period of life cycle management. So the life cycle considerations are necessary for the evaluation. And a bit more detailed sentences are given in the subclause 5.3, indicators for life cycle management. So as I mentioned already, that the social aspect be assessed, indicators objectively express the performance of the structure, okay? Such as the safety or of the structure or construction engineers and so on. And even it is difficult to set quantitative indicators for qualities as adaptability, comfort, cultural values, and social contribution. This shall be considered in social scientific manner. So some of the important social aspect indicators are not easily quantified. Okay? We can understand the importance of some of these indicators, but it's very difficult to quantify as a numerical values. In such a cases, but we still required to be considered in the social scientific manner. So this is the requirement of the social aspect. And the environmental aspect, okay, the indicators for the environmental impact in the execution and use stage of the structures, such as resource consumption, greenhouse emissions, and impact on the ambient environment, and so on. And for economic aspect, okay, cost, benefit, and the values as already mentioned can be provided, should be sometimes considered for these aspects. Okay, and there are some examples for the indicator evaluation in this document, but due to limitation of time, I'd like to skip this slide, but it is some concluding summary of the sustainability, how we specified in the ISO 22040. The next one is the ISO 19338, entitled Performance Requirement for Standard of Structural Concrete. It is developed at this moment in the TC71 Subcommittee 4 and Working Group 1, Performance Requirements for Structural Concrete, and its convener is Professor Sofia Denis in Brazil. Okay? This document was originally published in 2014, entitled Performance Assessment Requirements for Design Standards on Structural Concrete. Okay? And it was last reviewed and confirmed in 2019, and we decided to revise this document to more practical one, including the sustainability issues. So the left-hand slide shows the original document, the table of contents from chapter 1 to 8, and revised document possibly, it is not finalized yet, but possibly we'd like to add new chapters related to sustainability and sustainability evaluation. And some more minor revisions are already made for the table of contents. Okay. And for the general principle of the structural concrete design code, that's the purpose, function, the performance requirements of the structure to be ensured during the life cycle, during the design service life shall be determined. This performance requirement shall be appropriately selected as ability of the structure to maintain the function and the sustainability of the structure. So that performance requirement very close relation to the function and the sustainability of the structure. It is definitely declared. And sustainability concerns are given in another chapter, and some introductory statements are given here. And for the design and assessment approaches, so we add the safety, serviceability, restorability, structural integrity, robustness, sustainability, environmental adequacy, and durability. So they are the indicators what we are considered for the design and maintenance of the structures. And for the new sentences about sustainability, okay, among the items required of sustainability, those that can be quantified are recommended to be considered as performance requirements. This is a very important matter. Sustainability is not our effective items, but it should be included in the performance requirement if possible, if it is quantified. Okay, this document recommends to do it. And sustainability of the structure should be evaluated from these three aspects, and the design should be carried out so that each of these aspects can be maintained in a well-balanced manner. Because you can understand that social aspect, environmental aspect, and economic aspect, these three are not going to the same direction. If we consider the more environmental friendly structure, generally it is costed. Okay? And if we construct a more safer structures, it also needs more cost. So that the sustainability is not always the best result for our consideration. So we need a balance, okay, of these indicators. But it is very difficult how we balance the indicators. So we are still keeping consideration how we specify how we balance of these indicators should be included in this document. Okay. And also the principal design assessment with respect to the sustainability development, evaluation of performance should be conducted for these three aspects for sustainability. And it is preferable to deal with as performance requirements, as I already mentioned. Okay, and some aspects shall be defined based on the social and society and client needs. So these requirements, depending on the structures, or structural condition, or owners, or consideration, and so on. So this document cannot be specified how limit these indicators, but we just give some idea how we consider these indicators. I think that this is the same as the ACI towards the sustainability requirement. And also the sustainability requirement, okay, we should include some more sentences with such kind of situations. And life cycle approaches based on ISO 22040 is important for the sustainability evaluation. Okay, this will be added. The final one is the common principle of structural design for building of the civil infrastructure. This is a tentative title. This is under development. We established the Japan Society of Civil Engineers and Architectural Institute of Japan joint task forces to make a common principle of the structural design code. Okay, and I am serving as a convener of these activities. So this common code is not only for the concrete structures, but this can be applied regardless of the objectives, forms, and types of the structure and the material used. Okay, and also it can be applied for new structures as well as the already existing structures. We are now in the middle stages for the development, and we hope to the next few years to complete these work and it will be published. Okay, and the basis for structural design. Okay, this is almost the same as the ISO document as already introduced, but we emphasize the engineering value standard to be well specified for the service common code. Okay. A few minutes. Okay. And also the set of indexes based on sustainability are already increased, but it should be considered as the structural planning stages. And the performance requirement is the same as the ISO 19338. Okay, how the structure of the performance required to achieve its purpose, to ensure its function and to make the society sustainable. And the performance requirements shall be appropriately determined the ability to maintain the function and sustainability of the structures. And the level of the performance requirements shall be clearly defined, taking into consideration the social impact of the degree of achievement of the purpose and the function of the structures. Okay, and some evaluation indicators are also covered, will be covered in documents, and also, of course, the balance between these indicators are necessary. So the performance required included is the same as ISO 19338. Okay, such as functional usability, safety, stability, and restability, and also the ability to embody the sustainability is one of the performance that to be considered as a design. So this is the final, almost the final slide. So this is the idea of what we are going to specify the design regulation standard guideline to realize the sustainability as well as the life cycle management to realize the sustainability more objective manners. For this is the conclusion to my talk. As a performance requirement, it is recommended to explicitly determine the sustainability requirement of the structures. And the sustainability is one of the most important considerations during the life cycle of the structures. And it is necessary to consider the balance between the sustainability indicators. It is recommended to specify the requirement in the design standard code on how we consider, quantify, verify, and ensure sustainability of the structure throughout its life cycle. So thank you very much for your kind attention.